This is a lesson over how to solve one- and two-step equations. This is the foundation of solving any other type of equation that contains definitely more than one or two steps. The whole idea, though, is to be able to isolate the variable. We want to, whatever variable we're solving for, and what we're going to start off with is just one variable. We want to be able to isolate, get that variable on one side, and then the solution is what results on the other side. So the bottom line is, in order to solve an equation, we need to use what we call inverse operations or opposite operations to get that variable by itself. All right, so we're going to start with something that's very basic, and a lot of times when it is starting off as these one-step equations, we can sometimes just tell by looking at it. Just starting off with something very basic. X plus 5 equals 7. We just want to know what number plus 5 is 7. And you could tell by looking that it's going to be a 2 plus 5 equals 7. But how do we show our work? There's two ways. The proper way is to show using what we call the addition or subtraction property of equality, that whatever we do to one side, we do to the other side. So to get rid of this 5, this has a plus 5. We want to do the opposite, so we want to subtract a 5. And then what we do to that one side, we want to do to the other side. So now what's going to happen is that these 5s, they're opposite, so they turn into a 0, they cancel out, and we're just left with x is equal to 2. And then as a real quick way, we always want to check our solutions. And again, it doesn't have to be a written out step like this, but I just want to show you that if x were 2, we do get 2 plus 5 is equal to 7. But more importantly, we want to show this side is equal to this side. So just taking it one step further, we get a 7 on the left side and a 7 on the right side. Now, this is one way just to kind of keep it in the same line. Sometimes people need to look at things a little differently. So you might even see different approaches like this. If it's a little tricky to see it written out side by side like this, we could sometimes just write it underneath. What we're doing to one side, we do to the other side. We're going to see this used sort of in the elimination method when we get into solving systems of equations, that what we could do, and again, this is just a different way to visualize this, makes it a little bit easier, that these cancel. Now we have our x is equal to our 2 down here, that we simply just bring down the x, the equal sign, and then 7 minus 5 is what gives us our 2. What tends to make these problems a little more involved are the types of numbers we're dealing with. So everything was nice and positive here. If we looked at a second example, what if we had x plus 5 is equal to a negative 7? Sometimes now this makes it a little difficult, more difficult to be able to just tell by looking at it. But if we still follow this step, if I did x plus 5, where we still subtract a 5, I said subtract a 5 and wrote a 7 there. So if we still just show that we're subtracting a 5 from each side, and we just have to be careful here. So again, these 5s are opposites. They're going to cancel out. I'm left with an x. Now, if you have already watched my lesson on adding and subtracting integers, this is again how I explain this. We have a negative 7 and a negative 5. So think of this as you owe 7 and you owe another 5. So that would mean we would owe 12. So here x is equal to a negative 12. And again, we'd like to check this real quick. Substituting in negative 12 for x, we'll get a negative 12 plus 5 equals negative 7. And again, if we look at this negative 12, as we owe 12, but we have 5. So if you owed somebody 12, you pay them $5, you would still owe them 7, which is equal to the negative 7 on the other side. All right, so the first two were examples of when we had a variable that we were adding a number to it that we wanted to get rid of. in a way we had to subtract it. So now if we took a look at x minus 3 equals 2, we want to know what number minus 3 will give us a 2. Give us some time to think about it. You could maybe just tell by looking at it. But to show the opposite operation here, we have x minus 3. To get rid of a minus 3, we're going to add 3 to each side. And again, these 3's are opposites. They're going to cancel out. We're left with x is equal to 5. If we check this, we'll have 5 minus 3 is equal to 2. Again, 5 minus 3 is 2, but we showed that both sides work out. Another example involving subtraction here. What if we had x minus 3 is equal to a negative 5? I want to know what number minus 3 is going to give us a negative 5. Again, if I just follow the rule here of doing the opposite of a minus 3 would be to add 3. Add 3 to the left side. I want to add 3 to the right side. What's going to happen with these 3's? They're going to cancel. X is still left here. You owe 5. A negative 5 plus 3. Negative 5 plus 3 would give us a negative 2. If we check this real quick, we'll have negative 2 minus 3. Will that equal a negative 5? We owe 2. We owe 3. So negative 5 is equal to the negative 5 that's on the other side. Fifth example, let's say we have a 4x is equal to 8. This means 4 times x is equal to 8. 4 times what number is 8? Should come out to be a 2. But how do we show our work for this? If we have 4x is equal to 8, the opposite of multiplying, or the inverse of multiplying, is to divide. I'd like to divide the left side by 4 and then the right side by 4. So what's going to happen here, I don't really want to say they cancel because they're not giving you a 0. They divide out. The 4's divide out here. They turn into a 1. So we're left with x, and then 8 divided by 4 will give us 2. If we check this, 4 times 2 is equal to 8. So that works out. We just also have to be careful with negatives, and I will have a different lesson specifically designed for adding and subtracting negatives. I already have that posted, but multiplying and dividing and all the rules that involve with those types of numbers, positives and negatives there. So with, let's say if we have a negative 3x is equal to, say, negative 12. Again, the inverse operation of multiplying, that's negative 3 times x. I wish to divide both sides by the negative 3. Again, these negative 3's divide out. They give us a 1. So I'm just left with an x. And a negative divided by a negative is a positive. 12 divided by 3 will give us a positive 4. If we check this, negative 3 times 4, will that give us a negative 12? A negative times a positive is going to be a negative. So we get a negative 12 on the left side, which corresponds to the negative 12 over there on the right side. And the last type of one-step equations would be if we're dividing. So if I have x divided by 2 is equal to 5. I want to know what number divided by 2 is equal to 5. Again, just by thinking about it, it should be 10. 10 divided by 2 is equal to 5. But to show our steps here, the inverse operation of dividing is to multiply. So I want to multiply this side by 2. I'm going to write it this way as 2 over 1 because this is already a fraction. And then over here, I want to multiply by 2 again. So here our 2's divide out. They both give us a 1. I'm going to write it that way. So I'm just left with an x, and then 5 times 2 is 10. And just to check, 10 divided by 2 will give us a 5 on the left side, which matches the 5 on the right side. And let's just try it with some different signs here. If I had x divided by 3 is equal to a negative 5. What do you think I'm going to do in this case? I need to get rid of division by 3. Take this x divided by 3 and multiply it You're right, by 3 over 1. Same thing on the other side. I'll multiply that negative 5 by 3. These 3's are going to divide out, leaving me with x. And a negative 5 times 3 will give us a negative 15. So when I go to check this, negative 15 divided by 3, will that give us a negative 5? Yes, a negative divided by a positive is a negative. 15 divided by 3 is 5, so that matches the negative 5 on the other side. So I provided you with 2 examples each of just one-step equations. Next, we're going to take a look at 2-step equations. And now we're looking at the order of operations backwards. So we're going to take care of any addition or subtraction first. So use inverse operations of addition and subtraction first. I'm just going to abbreviate here. Then use any inverse operations of multiplication and division to isolate the variable. All right, so let's say we have 2x plus 3 is equal to 7. I'd like to get that x by itself. What I want to first undo, though, is this plus 3. So I'm going to have 2x plus 3. I wish to subtract a 3 from this side and subtract a 3 from the other side. So now these 3's are going to cancel. This 2x is going to be left here on the left side. 7 minus 3 is 4. So after taking care of that first step, I now have my second step here. I wish to get rid of this 2 that's being multiplied by the x. I'm going to do that by division. Divide left side by 2 and then the right side by 2. So these 2's are going to divide out. I'm going to be left with x, and 4 divided by 2 will give me a 2. Again, I'm always going to show a check with every solution here. If x is equal to 2, my check will become 2 times 2 plus 3. I want to know if that's going to equal 7. 2 times 2 will give me 4. 4 plus 3 will give me 7 on the left side, which matches the 7 on the right side. Let's say our second example, and sometimes we might get fractions for some of these answers. We never know what we're going to deal with. I'm just going to set this up as 3x minus 4 is equal to, say, negative 11. All right, so again, I want to start with taking care of this minus 4. So I'm going to have 3x minus 4. I wish to add a 4 to each side. So again, negative 4 plus 4 will cancel out. That will give me 0. 3x is going to equal, if I have $11 that I owe and I have 4, negative 11 plus 4 will give me a negative 7. Then I wish to get rid of this 3, so that's 3 times x is equal to negative 7. So I wish to divide both sides by 3. So in this case, 7 doesn't divide by 3 nicely, but that's okay. I'm left with negative 7/3. Most of the time, it's going to be okay to leave this as what we call an improper fraction. But this is why a check, showing the check, becomes very important here. So I'm going to have 3. I'm going to put this as 3 over 1 just because I'm going to multiply it by a negative 7/3 minus 4 is equal to negative 11. So this is where our problems become a little more complicated, is the fact that we can't always tell by looking. But what happens when we multiply or divide fractions? Well, 2 ways we could do this. And I'm just going to multiply straight across here. I'm going to get a negative 21 when I multiply 3 times negative 7 over 1 times 3, which is 3. Then I'm going to go through and simplify this. Negative 21 divided by 3 is going to give me a negative 7. If I owe 7 and I owe 4, I owe 11. And it matches the negative 11 on the other side. Let's just take a look at one more example. I might even throw another one in after this one. Let's say I have 6 minus 5x is equal to 1. So we have to be careful here. Notice again, we're used to seeing maybe our numbers being added or subtracted after the variable term. What I want to take a look at here is first this 6. This 6 is technically positive. So when I write this, I'm going to show 6. I'm just going to write it right after it. Minus 6, that's the new part I'm adding, minus 5x equals 1 minus 6. I did it that way to show that they're right next to each other. So I still subtracted a 6 from this side, and I subtracted a 6 from this side. So these 6's cancel out. The next very important part here is that we still have a negative 5x. We don't want to lose that minus sign. And then over here, a 1. I have 1 and I owe 6, so I would owe 5. Next, I would like to get rid of this negative 5 being multiplied by the x. I'm going to divide each side by negative 5. And x is going to equal, because these 5's, these negative 5's, divide out. And over here on the right side, a negative divided by a negative is a positive. 5 divided by 5 is 1. And real quick to show the check, 6 minus 5 times 1 will equal 1. This becomes 6 minus 5 times 1 is minus 5, and 6 minus 5 is 1, and we get that on the other side. And then this last example here is going to be very similar to the previous one, but we might have, let's say, a 15 minus x equals 2. So the same way that the last problem started is this 15 is what I want to undo first. Again, this 15 is positive. So I just want to subtract 15 from each side. And again, I chose this one because it should be easy enough to fill in the blank here. 15 minus what number will give us 2? We should expect a positive 13 when we're done. But let me actually go back and change the color here just to show. I want to subtract a 15 from each side. So these 15s cancel out. Keep in mind I'm left with a negative x. I'm going to talk about that in a second. 2 minus 15. If I have $2 and I owe 15, it's going to be a negative 13. Now just off to the side here, I want to show you negative x is the same as saying a negative 1 times x. So technically I could squeeze in a negative 1 here. So in my next step, I wish to divide by a negative 1, which will give me, again, these negative 1's will divide out, and x will equal negative divided by negative is a positive, 13 divided by 1 is 13. Or off to the side again here, if we look at the opposite maybe. So the opposite of x is equal to the opposite of 13. So if I took the opposite of each side, if I made this positive, really like what I do to one side, I do to the other side. So these are several different ways to look at this. But let's just show the check real quick here. If I have 15 minus a 13, I will get 2. I'll get a 2 on the left side, which is equal to the 2 on the right side. So just an introductory lesson into solving equations. I will post several more lessons over solving different types of equations. They will include using the distributive property and having variables on both sides. So just keep scrolling through the different lessons I have. And as always, if I don't have a lesson that you're in need of, please feel free to email me at help@thealgebratutor.com, and I could post a video just for you. Thank you.